A1, I work for A1 DesignBuild. I'm one of the co-owners. We're a worker-owned cooperative, and I manage the design department. In the last couple of years, we've worked quite a bit with Habitat for Humanity, trying to help them do what they do, and that has been a really successful partnership, and I will table that until the end and let Hillary explain more about their projects. I think what I'm going to do right away is just dive into what is Passive House and how do we make it affordable. So I'm going to share my screen. I've prepared a little slideshow. So let me do that. And hopefully what you're seeing right now, let's see here, is A1 DesignBuild moves towards passive full speed ahead. Is that what everyone's seeing?
Looks great, Maggie. Thank you.
Okay. So A1 Builders has been around for like 50 years. And about 3 years ago, it became a worker-owned cooperative and we rebranded as A1 DesignBuild. And in that process of kind of reorganizing our company, because the owners were retiring and they sold it to the employees, we also were able to really take hold and take it into the next phase of green building. It already had a reputation as being a green builder, but we wanted to really take that farther. And so basically 3 of us in the company kind of have spearheaded that. We've got Mike Feeney, myself, and Sean Serdal, who have all gotten certified in Passive House design. This basically created an educational they created an educational platform and then a certification platform for certifying your buildings. At this point, we've all gotten our certifications in our profession, and we're moving towards finding the right clients to match up with these skills to make certified passive buildings. So what is a passive house? So let's just look at the principles first. It is a very comfortable house, it's a very durable house, and it's a very energy efficient house. So we get to that by insulating the house in a manner that's very, contains the whole envelope, including underneath slabs, not just walls and attics. Then it's kind of like putting a really great sweater on. And then we don't want the water and the air to go in the wrong direction. We don't want water coming in. We don't want warm air escaping out. So it takes a lot of vapor and air control layers, and at every intersection of a wall to a roof, or a wall to a slab, or where there's an opening for a window or a door, there's an incredible amount of planning done of how the surfaces will overlap, how will it actually be sealed. So it's a building science heavy process to create a passive house. So basically we're gonna have the really great sweater, and then we're gonna also have a raincoat that kind of blocks the wind on our house. And then we've got this really nice airtight building. Well, what about fresh air? And especially as we're going into these warm days, we're going to remember last year when we had all the fires, and you know, we're all trying to figure out how do we keep the inside of our house healthy. And that can be done with a heat recovery ventilator. So we are really paying super close attention to keeping that air fresh and healthy inside the house. And then we're also going to think about, where is the house in location to the sun? Can we use solar to help power this house? And we're also going to be thinking about what do we put in this house to heat it? What do we put in this house to run the lights, to live in it? We're going to have things that require power. So in a passive house, we try and limit how much power we're going to use, especially for heating and cooling, but everything is taken into consideration. And if possible, you would move towards a net zero house with passive, but that's not always possible. And why would that not be possible? Well, we live in a very cloudy world here in Bellingham. Some people like to live in the woods, and it's not a great place for solar. So what's the next best thing you can do? Or what is the best thing you do in combination with solar if you are going to do solar? And that's to make your house as energy efficient as possible. So a passive house, even if it doesn't have solar, the idea is basically it is so efficient, so well built that you can heat it with a blow dryer. A little bit of an exaggeration, but that's the idea. So in passive house, I got to keep an eye here because I can just talk and talk. So I love this subject, and I've just gotten so much information in the last few years about how to do this well. I'm going to keep an eye on here. If anybody has any questions, just chime in. I'm happy to answer. With passive house, we're gonna want a much higher. We're just going to look at R values right now to kind of compare. What is a passive house compared to a regular house? In green, I show passive Marine 4. That's our area here. And then in blue, I show the Washington State Energy Code for Marine 4. The difference is R31 walls in a passive house versus R31 to 43 versus R21 in a regular, new building in Washington State. Ceiling, again, 60 to 70 compared to 38 to 49 in R values. And then the slab is an R20 under the entire slab and down the edge of the slab, whereas with Washington State Energy Code, it's half that. So the first thing we do is in passive is that it's a much better insulated house. The windows also are quite a bit different in a passive house, and you can get there with triple pane windows. Washington State Energy Code requires that we meet a U factor of 0.3, whereas passive house asks us to get quite a bit lower than that. And for instance, we have built a couple houses in the last couple years where we have integrated a lot of the passive house principles. The owners of these homes did not want to go as far as getting certified, but we built with certification in mind. We built with high performance in mind. And how do they measure up? For instance, this house that's under construction right now, the windows, instead of being a 0.30 U factor, are a 0.26. We didn't do anything special on the slab. We just met energy code on that. But on the walls, we went all the way up to R26. And on the roof, we went up to an R50. So this house, it far surpasses the Washington State Energy Code. It will be more comfortable and more durable because of the products that we chose. And that all falls into the passive house thinking. Here's another house that we're working on right now. It's under construction. It's a very unique house, and I will probably bring it up a couple times in this talk. It's also not certified, but it is moving in that direction. In this case, we have done 0.17 on the U factor on the windows. They're triple paned. Really heavy windows. When we went to actually put them in, it was amazing how heavy they were. I had to actually carry one of them down so that I could get a color match on some metal, and I'm like, whoa, this is heavy. Much heavier than a regular window. And the field crew said the same thing. We put an R20 under the whole slab, so basically we've got a couple inches of insulation under the whole thing. Actually, I think that's 4 inches of insulation under the entire slab. The walls are an R25, and the 6 panels on the top of the roof are an R49. So last fall, in order to educate the folks who in the company who had not become certified in Passive House, we were basically sharing information, and we said, well, what would happen if we all just designed one when we have some downtime waiting for our regular clients to call us back? Go over and work on a passive house, see what you can come up with. And we had some project goals. We said, let's do a 2-bedroom, 2-bath, make it economical, high performance structure, passive friendly, R values and air sealing, windows and doors, downsize, efficient appliances, appropriate HVAC components. Everything should be Energy Star and solar ready, and make it economical. Well, you see this 800 square feet at the bottom? This is the first thing we figured out, is we have to keep this small if we're going to make it economical. So I'm just going to go quickly through here and show you some of the basic, this is just a little lookbook of the basic designs that our crew came up with. And you look at the simplicity of these structures. This is what helps passive buildings succeed, is to not make them too complicated with too many roof lines, too many angles in and out on the building, because every time you do that, you're creating a corner. And every time you create a corner or you add something onto the outside of a building, you possibly are going to be creating a thermal bridge, which is something that we want to avoid. So this is, when we're talking about affordable housing and passive, we're talking small and simple. It doesn't mean that it's not beautiful. And most of these designs that our crew came up with were pretty modern looking. You know, you can do something though that is more traditional. This kind of looks more like a 50s style. And then I think we've got one in here that even looks like a little gable roof. So passive can be designed any way, to look any way you want, as long as you incorporate durability and simplicity in the design. We can pull off some other things that are more interesting. And that's just a recap of what we were trying to do with this. So let's look at some of the numbers, which is, you know, we were a little shocked, but not terribly shocked, because building costs have gone up a lot in the last few years, and especially in the last year. And by the way, these numbers here for square footage for totals do not include the most recent lumber increases, which are quite insane. But square foot cost is running, you know, from about 500,000 and up, depending on what components we included. So we looked at basically a Larson truss wall, which is a double wall. I'll show you a detail of that in a minute. We looked at partial SIPS walls here, SIPS walls here, and then we looked at a Foswall block, which actually I showed you earlier in was one of our new constructions, was a Foswall, and I'll talk about that some more. And then, yeah, the last one was a Foswall also.
Hey, Maggie.
Yes.
You might bring this up, but there's a question in the chat about what type of insulation you guys are using in order to meet those benchmarks. And that was from Mike.
Okay, so we are using, depending on the building, we're using a lot of SIPS panels these days, which is foam insulation. And we also are in the Foswall block house that we're doing. It has a foam insert. You can also do that with a rock wool on the end, which is a mineral wool insert. I'll show you a Foswall block in a moment and show you how that insulation works. One of the things that we're doing on retrofit buildings is we come back in. So let's say you've got a 1930s Rambler. There's a lot of people out there that have those kind of buildings. And so you've got a 2x4 wall. So you're gonna put whatever insulation you decide is best for that structure. It could be fiberglass, it could be rock wool, it could be foam inside those older walls. And then on the outside of that wall, we're gonna add, if it's a resurface, like if we're taking off the siding and redoing the windows, we're going to add a continuous layer of foam insulation or Roxol, which is a mineral wool. It's a rigid mineral wool on the exterior. And that's going to break all the thermal bridging from the outside into the house. And then we'll reinstall the siding on top of that and the windows on top of that. I hope that answers the question. So we're kind of open to all different types. Foam, which has, foam is it's a super good insulator. It's got some, it's got some non-green aspects to it, but as far as economy and efficiency, it's really hard to argue with. Roxol is another one that I actually really love. Roxol, which is a mineral wool. It's pretty inert. It resists bugs. It resists water. It resists so much. You can also, so those two are great on the exterior of the building. When you get into the interiors, you have more options. You could go with a blown-in cellulose or a fiberglass. So when you're considering a passive house, you want to at least think about solar ready if you've got access. And this is a remodel, actually, an addition that we did a few years back. And this one had skylights that we planned in with the solar panels. So you want to think about where the house is in relationship to the sun. You want to think about the pitch of your roof. You want to think about where the house is in relationship to the trees around it. And so site orientation is very important. Then you want to start thinking about what is the structure going to be made of. Here's the false wall blocks I was talking about. This happens to be mineral wool in here. So I'm going to take a moment now. This is not a passive house criteria that I'm going to talk about, but it's a very high efficient method of building, and it creates something that they're not even counting in passive house these days, and that's thermal mass. So if you can imagine a building made out of these blocks, we've got the insulation towards the outside. In here, we're going to put the rebar that's going to give it all the structure, and then we're going to pour concrete in there. So now the heat is on the inside of the building. The heat's going to migrate into the concrete, and then it's going to be held there by the insulation. And so you've created this amazing thermal mass on the inside of your building, which is a really great way to go if you want to hold heat in your building. Let me jump over here to this one. This is a SIPS wall, which basically is a structural insulated panel. So it takes care of the strength you need, and it's continuous insulation all the way across the entire wall. Super efficient. Here's an example of a Larson truss wall, and out of those earlier numbers I gave you, this was the most expensive thing to build, and that's where basically we're building two walls, double insulation. The idea here is you're getting the wall as thick as you possibly can so you can pack in more insulation, and then you're going to offset your joist system so that you don't have thermal bridging going all the way through the house. Here's what I was talking about earlier. This is an example of a retrofit on the right-hand side, and these heavy blue lines you see are where we added continuous insulation on the outside of the building to avoid the thermal bridging. What else did I want to? Yeah, so the comparison though, in a brand new Larson truss wall, we got up to an R value in the wall of 45.5, whereas in this retrofit of a cabin out on Toad Lake, we got up to just an R23, but it started out at an R15, so we made quite an increase on that. R45 really, I believe, is a little bit of overkill for our climate. I don't think we need to get quite that high with our R values. So this is an example of where we would use a SIPS wall and we would use a SIPS roof. And then here you can see we're actually adding insulation all around the footing in this plan. And I have a little photograph I'll show you later where we've actually sent off some plans to a company that makes they make SIPS panels, and they will actually create foam footing forms for us, which is very cutting edge, and it's still in development. And it's, you know, we don't want to keep it a secret. We want all the builders to be doing this, but we might be the first one that's getting our own produced. I'll show you a picture of that later. And then let's talk about the foam. If you are going to go with a foam, there's a new thing that's happening, and that if you see here, this is what we're all used to seeing with a SIPS panel, which is white foam. But here we are with the same thing with gray. And all they've done is they've infused graphite into the foam, and it increases the R value of the foam. I think it would increase, like if you had an R38, I believe it would be like an R38, I think it's 9 inches thick. And if you added the graphite infusion to it, it brings it up to an R49. So it's significant. Oh, here's the picture. So these are just little cross-section cuts of what a footing form might look like if you were going to insulate your footing. And so we had these made up just recently by a company in Colorado. We're trying to find a company closer to us to actually manufacture these, because it's expensive to ship foam, not because it's heavy, but because it's so big and bulky. So this is kind of an experimental stage. So when we're thinking passive, we're thinking from bottom to top. That's why I bring up these footing forms, because that's where we want to go eventually, is to insulate our footings. Some of the passive houses out there are already doing this. None in our area that I know of, though. And then, so I've already talked a lot about the walls, but then when you get up to the roof, let's say you're going to do a trussed roof. Well, you want to make sure you have an energy heel on there, because you want to be able to put a lot of insulation up in your attic. And what else can I talk about here? Oh, on passive house, we want to keep everything inside the conditioned floor area. So if you have anything running on a ducted system, if you have, even with electrical, we don't really want to penetrate and go up into the attic. We don't want to put our ducting up in the attic. We want everything inside the conditioned floor area. So inside your drywall, if you could picture that. So this right here, this picture in the bottom right-hand corner is, these are floor trusses, which normally you see trusses in attics. We're all used to that. But if you put trusses in your floors, now you can run piping, electrical, you can run HVAC through your floor system. You don't have to be going up into an attic to do it. You've got a place right there. It's easy to get things through. So I highly recommend this. And there was a passive house architect who visited us a while back, and she's the one who got me thinking this way, and I think it's just the best way to go. Another thing we're gonna, yeah.
There's a question in the chat. How much are you increasing the energy heel? More than 16 inches total?
You know, I'd have to, let me think about that. 16 inches total. No, we wouldn't have to increase it more than 16 inches. No. Because if you think about, if you're just trying to get, if you've got a, if you're trying to get an R60, you should be able to do that in 16 inches.
Okay.
Yeah, I actually, for those kind of questions, a lot of times I'll go off into my world and I'll start calculating and researching, and I don't have it in my head. Great question though. Yeah, I think 16 inches would do it though. So Passive House also recommends that you go very efficient on your windows. So just for real basics, this is a double pane window down here in gray on the right, and next to it is a triple pane window. Up here in the top is also triple pane window. If you notice on the red windows, see the gray, they have insulated the frames themselves. You do not see this on regular windows. Any regular window that you go down and buy at Lowe's, you are not going to find insulation in the frames. Over here, we don't have insulation in these frames. They have steel reinforcement in their frames. So this one is Cascadia windows. This one is Inotech. Inotech will pull out the steel frames and they'll put insulation in there if you want to. But I have found that I can use these triple pane windows if I over insulate on the outside, which if you look at this drawing, that's what I'm doing. So here's a triple pane window. And normally this little detail here is foam, and that's called over insulating. So I'm over insulating where the thermal bridging and the framing is so that I can block that cold from really penetrating that window. This is a better way to go, but it's also very expensive. This is a more affordable way to go. Very durable, very long life to those. Another thing we want to think about with passive house is it's how we heat our water and how far do we make that water travel. It's really recommended that you keep your fixtures close together. It's probably easier to do, oops, I thought I had, oh darn. Somehow when I was doing my edit, I deleted a slide, but I can explain it to you. Basically, you want to think about your hot water heater being in, say, your utility room. And in this case, I show here that it's a Sandon hot water heater, and that's where the hot water heater sits inside your building, and then there's a heat pump right on the outside of your building that heats your water. So now we're not depending on gas to heat our hot water. We have a very efficient way to heat hot water with a heat pump. Then once the water's hot and you want to take it to your kitchen, your bathroom, your shower, you don't want to have to travel, you know, miles across your building. You want to keep your plumbing, you plan your rooms so that maybe you're stacking your bathrooms or you're keeping things within, you know, 15 feet maybe of where the hot water is. That's ideal. A lot of times when you get to larger houses, you'll see people putting in hot water heaters in multiple places in their houses. Yes, you can do that. Is that going to create an affordable, economical house? No. So planning your plumbing fixtures, your hot water fixtures to be in close proximity to the hot water tank is a great idea, and it's very passive friendly. So another thing that that is required with passive house is that ventilation that I talked about early on, and this is a heat recovery ventilator, which is not your heating system. All that means is that we're going to take stale, smoky, noxious air out of the building and bring in fresh air. As we do that, so let's just look at this house. I love this. This is from Zender. They're showing us in these red lines here. This is air that is noxious. It's polluted. You know, it's smoky or smelly, or it's got moisture in it that we want to get rid of because we're cooking. So it's going to go out of the house. It's hot. And it's going to go, if you see back in the corner, the red is going down into the heat recovery ventilator. So as that air goes out of the building, because it's going to go into this heat recovery ventilator and straight out of the building, the heat from these rooms is recovered in this little mechanism right here. And then we have fresh air coming in from outside, which they are showing in green here. The fresh air comes in, and that air is warmed before, it's shown in yellow here, it comes into the heat recovery ventilator, goes up through this pipe and out into all the rooms. It goes into the bedrooms, the living room, it goes into the fresh air, where you want fresh air to happen. And then this is completely balanced. This system is balanced so that the amount of air being pulled in balances with the amount of air being sent out. This system replaces bath fans. You don't have a typical bath fan. You don't have a high-powered typical oven hood that's sucking, 600 cubic feet per minute out of air out of your house. Instead, what you have is a very small amount of air being constantly circulated through all of the rooms. And it's very balanced, it's very fresh, and it's constant. It's very quiet. I've been in houses with these. I haven't lived with one, but I've stayed in a house for a couple weeks that had a heat recovery ventilator. You can't hear it. When you want to, when you want to boost it, say in the kitchen, if things get too steamy, or the bathroom, things get too steamy, you want to boost it, you can flip a switch and it boosts it, and it goes on a little bit stronger for a short amount of time, then it goes off. This is the direction that I think all houses are going to have to go eventually. Because just thinking in terms of our local problem is smoke in the summertime now, and it's cold air in the wintertime. So we want to be able to control the air on the inside of the house. That doesn't mean you can't open your windows. It doesn't mean you can't use screens. You absolutely can. You can live life as normally as you always have. But when you have to shut everything up, it's going to be super efficient. You're not going to lose heat or cool, depending on the time of year, and you are going to have super fresh air.
Hey, Maggie, there's a couple of questions in the chat.
Mm-hmm.
And we are also at about 1:40, and I think they want to end these about like 1:50-ish. But we could probably stay on for some Q&A and stuff. So Mira was wondering about hot water, on-demand hot water heating. And then Thomas had a question about, do those booster switches for the HRVs ramp up the entire home's ventilation, or just for a certain location?
Just for certain locations. Can you repeat the first question?
On-demand hot water heating. How does that play into the explanation that you were talking about with the plumbing and keeping all the plumbing and hot water localized?
The most efficient on-demand hot water heater is gas, and gas is not passive house friendly. We try not to have any gas in the house at all. There's a few things that you kind of have to accept that people will not give up. Some people will not give up their gas stove for cooking. Some people will not give up their gas fireplace. But when it comes to hot water, we're saying don't use gas, don't use on demand, use a heat pump hot water heater. Yeah. Passive house is not really gas friendly. It's the house is sealed up super tight. It's just better if we can go with all electric on pretty much everything. So I'll try and scoot through this a little bit faster. The heat pumps are a big part of it. You want to plan for heat pumps and there's ducted and ductless. There's a couple ways you can go. The heat pump hot water heater is we just talked about. And then I actually am towards the end here. Energy Star on all your appliances inside is required. LED lighting or equal is required. One of the things that people don't really realize that actually works great is a recirculation hood over your stove. You've still got your kitchen is being ventilated with your HRV, but it's a little bit farther away from your stove. So right over your stove, you can filter out any smoke with a recirculation vent with a charcoal filter in it. And these things here are not these are not lighting fixtures, although there is light in them. These are actually recirculation vent hoods. So there's some really cool things happening with vent hoods. You can also get a heat pump washer dryer these days. You don't have to you don't have to vent your dryer to the outside. You can, I have one, and it's amazing. It works great. So we're trying to minimize the holes in the house, honestly, wherever we possibly can. And that's going to take us to the end of basically my passive talk. Basically, we had a lot of craftsmanship and big projects that we had to tackle. And our ability as a team to get really strong in handling whatever came our way is now being funneled into these high performance buildings, and we're moving towards passive house more and more. Okay, any more questions in the chat? I'm going to stop sharing my screen.
Maggie, that was a really good presentation. Oh, I was going to plug a lot of the stuff that she just talked about is in the home tours that we have on the main page. So if you want more examples and localized examples of what this looks like, check those out for sure.
Yes. Okay, so thank you so much, Maggie. And that actually covers a lot of what I have as a presentation. So I'm going to go ahead and share my screen. My name is Hillary. I'm with Habitat for Humanity. And we have used really a lot of these techniques that Maggie has been talking about in some of our construction as well. And so that was a big thing that that we had wanted to bring up is, you know, how do you even have to, you have all these things that are in passive house. What is actually appropriate for your house, whether you're doing a retrofit, whether you're doing a new construction, anything like that. And so, you know, for a super quick overview, Habitat for Humanity, we build homes from the ground up as an affordable, we are a not-for-profit building affordable home ownership opportunities. There's an international organization. We're all working to help eliminate poverty by building homes for people. And here locally, Habitat for Humanity works in Whatcom County just for Whatcom County residents. And I'm going to keep going back to this. We are building homes so that they are as affordable to operate, energy efficient, very user-friendly and low maintenance to actually operate, because we want to build affordability not just for now, but for 10 years down the road, 20 years down the road. And it doesn't really help our home buyers if they have to be buying a whole lot more or paying high maintenance costs or high replacement costs. So we want to make sure that all of these things that we are incorporating into the home's construction or into the home's interior are really are really economical to operate as well. So now, before I go on, I am going to say I don't have my chat on, so please interrupt me if you have questions. Otherwise, I'm going to try to go quick so that we can have some more time for Q&A. And the other part with Habitat for Humanity is, so since we are a home ownership program, our goal is we are selling these homes to our clients, and the money that ends up coming back to us ends up being actually recycled in the construction of new homes. One of the biggest ways that we can actually do that and that we can fund these projects is volunteers. We have volunteer crews who are coming in to help build these homes with us. And so we also need to make the construction techniques that we are utilizing volunteer friendly to build. We build simple, decent, and affordable homes is our tagline. And that's key. So the Habitat clients that we're working with, again, they're Whatcom County residents, typically living in some type of substandard conditions, whether it's overcrowding, poor construction, dangerous neighborhood, things like that. They have an income that is below 80% area median income. Typically with Habitat, we're working with clients who are earning between the 30 to 60% area median income. So for Whatcom residents, what that actually means is a family of 4 would be making between $25,000 to $51,000, right? So if you're a first-time homeowner, it's not enough to actually get into a home. With the rents nowadays, it's really basically enough to be a renter. But we're also looking for folks that demonstrate that they have an ability to repay us back, since it is a mortgage. And they also do a deposit of $500 and put in 500 hours of sweat equity. The time is really their deposit. So things that we're building. This is one that we just completed in Sudden Valley. And I'm showing it to you first because we are building a carbon copy in another part of Sudden Valley. And these homes are all built with passive in mind. And again, like Maggie was saying, where, you know, this is Sudden Valley, it's heavily treed. You're not gonna put solar on these homes because it's not gonna have the return on the investment that the home buyers need, but there are other things that we can do. So this is a single family home that's currently under construction. Also, we have our flagship project that we are working on with the Colchester Land Trust and Whatcom Community Foundation. These are 8 townhomes that we completed on Telegraph Road, and we're building another 4 right over here behind the tree. You can basically see cleared area over there. And I'm gonna go back to this, building simple, decent, and affordable homes, because we need to make sure that everything we are doing is gonna work for our home buyers. So when we're building, our board of directors looked at the passive house model to try to see what elements of it that we could incorporate. And they found that there are certain things that you can do that have a great return on investment for our home buyers and don't add a whole lot of extra cost to the cost of construction. And most of those ended up being the triple pane windows that Maggie was talking about, heavy insulation that she was talking about, and that extensive ceiling. The crafting the home to make sure that there are not too many corners and bump outs and spots where you're going to have to make sure that it's sealed or that there's no thermal bridging. All of that really ends up increasing the cost of a new construction and for any additions and stuff that you're actually putting on. So even things along the lines of making sure that you're using materials to the fullest extent possible. You know, things come in 4x8s or often in 2-foot increments. So are you building to actually be economical with the products that you're going to be using? And keep going, PowerPoint. There we go. So here is a picture from our Telegraph Road project. These are the 4 units that are currently under construction. And you can see we're using a 2-inch insulated zip system panel to build those that continuous layer of insulation along the outside. And actually, this is at our Telegraph Town project. We're building it actually different in the Sudden Valley, at the Sudden Valley home. And we are using, I believe it was the Larson Truss style of construction that Maggie was talking about, with the double wall and then cellulose insulation in the walls to create that thermal break and to create an 8-inch thick wall that's super heavily insulated. And you can see the 2x4s are staggered. So there's 2 sets of 2x4s. And part of the reason that we are doing that is because volunteers like to build walls. So when you're paying a crew, yes, it's more expensive. But when you're handing volunteers nail guns and they are happy to nail walls together, then it's a little bit less expensive for us. We have what's called a zip wall system. And this is basically a combination of your wall sheeting with your Tyvek is essentially what it is. It allows moisture to go out, but not to go in. And then you tape the seams and you can create a continuous moisture barrier for the home. We have been doing the heat recovery ventilators, and those are huge in terms of making sure that our homes are well ventilated, lower cost to heat and to cool, and very low maintenance. These things basically have a filter that you need to clean out, and you need to not turn them off. That's kind of about it. and you just need to pay attention to them like you would any other thing in your home. But they're extremely quiet and very, very easy to use. And here's a photo of actually Sean coming out to do a blower door test at the Bramble Way home that we completed in Sudden Valley. So I wanted to throw that one in there. And of course, making all the homes solar ready. Like I said, down in Sudden Valley, we're not putting solar panels on the homes because there's just too many trees. It's not useful. But at the Telegraph Townhomes project, we are, and we are making sure that all of our homes are solar ready, so that should a home buyer choose that they want solar later, it's much easier for them to do. And that is pretty much the end of my presentation. Hopefully I didn't go too fast. Yeah, there is a tour. One of the Matterport tours is of one of the townhomes that we have built out on Telegraph Road. That's the project with the Colshan Community Land Trust. So you can click on that and go cruise around through the home and see what it has. And the make and model of triple pane windows that we are currently using, cost effective. Okay, I can speak to that. So we are using Plygem windows is what we use. And actually part of that is because there's a national program that Plygem has with Habitat for Humanity, so we can actually get a discount on some of those. So
thank you so much.
Anybody have any questions?
Yeah, if anyone has any questions, I do just want to say we can leave this room open.